All right, hello guys. Question number 7, find the Taylor series. And for finding the Taylor series, all you got to do is just find the pattern. And so 4 to the negative 2x is the same thing as e to the negative 2x, right? Because this is technically just a number. And so when you derive e to the negative 2x, it's just e to the negative 2x times the derivative of the top, which is negative 2. And so when you're doing this, you use the same exact process. So you get, and obviously, back to the Taylor series, when you want to find your Taylor series, you want to find the pattern. And so this is at your n0, and this is at your n equals 1. And so that's your first derivative, which equals, like we said, 4 to the negative 2x times, if I can make beautiful brackets here, times to the negative 2, which is the derivative of the exponent. Okay, and then we do it again. N equals 2. Second derivative equals, same thing, 4 negative 2x, negative 2, and again, times it by negative 2. And if we do it again, we know the pattern is going to be 4 minus 2x again. And then we continue this, and then add one more. And this is our n equal 3. And now let's write our pattern. So what is our series? And so we know our Taylor series equation is your sum from n at 0 to infinity. And your Taylor series goes f at n at x all over n factorial x minus a. And I believe this is not x, this is supposed to be a as well. Whoops. All right. And so here to the n plus 1. I'm not too sure of this. Let me confirm and I'll get right back to you. Yep. So this is a given equation on the formula sheet on the exam. And this is the equation. And so how do we get our fn at a? Right now I'm not subbing in my a because I just want to find my pattern first. And so my pattern that I'm looking at is, what is it going to look like? We have fn at a equals, we have, as we can see, the 4 is a constant, so that's our 4. And we know our exponent is to the negative 2a, and that doesn't change, right? That doesn't change. And the reason it's not x, it's a, because we're doing it in terms of a, right? And so this doesn't change, and it will always stay there, as we can see when we're going down, our ends. And so my second term is negative 2. And so as you can see, in your first n0, there is no negative 2. Then in the second one, at n equals 1, there is one of them. And so we can say this is 2. You see, if I put it to the n at 0, so 2 at 0 equals 1, which is here. There's no 2. And then 2 at, n1 equals 2. And we can see it's right here. Yes, I didn't include the negative. We're going to deal with it in a bit. And as you can see, 2 to the squared at n equals 2, which is here, is 2 times 2, which is, this is truly 2 times 2. And so this is valid so far. All right, now we got to deal with our negative. Your negative, the way you can control negative is always at negative 1. This will always be it. What you're looking for is your exponent here. Okay, so your exponent can either be n, and let's test it. And so if your negative 1 is to the n0, this will equal 1, positive 1, which will give you a positive number, and this is positive. And if I do negative 1 to the 1, this will give me a negative 1, and this is negative, right? And then negative 1 to the 2, this will give me a positive. When you square up a negative, you get a positive. And you see negative 2 times negative 2, positive, right? And so that's how you can represent it. If you want to do it the other way, you can do plus 1. This will turn it where at n0 will be 0 plus 1. So we'll give you a negative 1 actually. Okay? So that's the other way you can write it if you start with a negative. But here we start with a positive. So this is what we're actually looking for. Now, since these two are the same, question is, can I combine them and do 4 negative 2a at negative 2n? This is also valid because when I plug in 0, I will get negative 2. to the 0, which equals 1, right? Which is right here. Positive, there's no 2. And then at negative 2, 1, what I'll get is a negative 2, which I do. And then when I do a negative 2 at 2, I will get negative 2 times negative 2, which is also what I got here. And this will give me a positive number, right? And so yes, this is valid, and I could shortcut it into writing it like this. Now all you gotta do is really plug your stuff in. And so if I simplify this, this is 4. Negative 2, I have my a is negative 1. Negative 2 times negative 1 is just 2. And so I could rewrite this as 16. And 16 times negative 2 to the n. That is your formula. And now what you can do is apply it here. And so your sum is going to be your 16 negative 2 to the n all over n factorial at x minus plus 1, because minus minus 1 is just 1, and to the power n. Now, another thing that you always want to confirm is that plug your n in, okay? Plug your n at 0n and see if you get 0, right? If you get 0, then you want to start from 1, okay? And so if I plug it in, if I plug this 0 in, negative 2 to the 0 is going to be 1. So this is the top here is going to be 16. The bottom is going to be 1. So it's 16 over 1. This here will be to the 0. So this will turn into 1. So I actually get 16. Therefore, I will leave it at n equals 0. But assuming I did this operation and I got 0, then I will remove this and I'll start at n equal 1. Okay? So keep that in mind. Determine the sequence converges or diverges. 1, 8, well, I can't speak. A equals n. Oh, these are two separate questions. Okay, so to check if a sequence converges or diverges, there's a test that says if the limit as n goes to infinity of your a of n is a number, then it converges. However, if it's like infinity, negative infinity, dne, then, you know, diverges. It's a pretty simple test, but the only thing with this test is that this only works on a sequence and not series. Do pay attention. This only works on a sequence, not series. All right? And so doing this, what I'll be getting here is I'll be taking the limit as n approaches infinity. If I can write beautifully. I can't. I gotta practice writing, not math. There you go. Of n over 1 plus root n. Right? Now, how do we take the limit of this? First, what I like to do is raise it. So I'll do n over 1 plus n to the 1 over 2. Right? Make it look cleaner, let's say. Right? And now what I can do, just divide by your denominator. That's usually what you do. You divide the whole thing by denominator. Now, why can I do this? I'm dividing the top and bottom by n to the half, or root n. And that I'm just trying to divide basically 1 by 1. And so it doesn't change the question. That's why it's allowed. And so what I'll get is n over n 1 over 2 all over 1 over n 1/2 plus 1. Right? That's what it looks like now. How can I simplify this even more? When you divide, when I do like x squared divided by x, it becomes x squared minus 1. Right? That's what it actually looks like. And so this is actually 1 minus 1/2. Right? And so writing this, what I will be getting is n to the 1/2 over 1 over root n plus 1. Now, let's assume I don't know the limit of this. How can I take the limit? So let me rewrite it as like proper syntax. So limit as n goes to infinity of your root n over 1 root n plus 1. Where does this go? Now, what I'll do is I'm going to go to my calculator. I'm going to do 1 divided by, and I'm going to do root n, and then let's say I'm going to put 10. What I got is 0.31. Now, if I put 1,000 or a million instead of the 10, like in n, what I got is 0.003. So I know as this number, as my root n, as this number gets very big, the number gets smaller and smaller and smaller. So eventually when I go to infinity, I'm actually going to 0 because, you know, I'm going to infinity. So this is infinitely small. So it's going to go to 0. Okay. And so what you'll get is this goes to 0. Okay. And so now what you'll end up with is you'll have root n over 1. Okay. Because this goes to 0. And so now what I do here, I'll do a root again. Well, root n over 1 is just root n. I don't know why I did that. Root n. And so now, if I do root n of 10, I get 3. And if I do root n of a million, I got 1,000. So as I go to infinity, this number will keep growing and growing and growing. And so this will actually go to infinity. Therefore, it diverges. Okay. Now we're doing a ln. Let's see. This one, it's basically about the same. You want to take your limits. All right. So continuing to this question below, we're taking the limit as n goes to infinity of an, and so then you take your limit of n goes to infinity of your in of n minus in, or it's not in, it's ln, but plus 1. Okay, and so when you're taking the limit, if you pay attention, you remember your arctan, and you're gonna be like, why does this relate? Your arctan, when you do tan inverse of like 1,000, you'll get some number which is the same number as if you did tan inverse of like 1 million, because it actually plateaus at negative pi over 2. But for your ln, it's actually, even though the graph looks similar and you might think it's similar, like this, right? It doesn't actually plateau at a number. So it doesn't matter, as it goes to infinity, this number will keep going, unlike tan where it'll stop. And so this will actually, when you take the limit, your ln at n will actually go to infinity as well. Oops. Okay, and so your ln at n will go to infinity. Will go to infinity minus your ln at infinity squared plus 1 is also infinity, right? And so this is just, it just goes to infinity, right? And so it diverges. Okay. Use any method. Okay, so this part is for the paper exam. It's not actually on the exam that we're doing right now. And so this part is for ratios, which is not on the exam for the online, but it is on the exam for the paper. Determine whether the series converges or diverges. See, this is now a series. And so for a series, what you'll do is, your a plus ar plus ar squared. And so we know this is my a equals 5. And I know my ar equals negative 5 over 4. Right? This is right here. And this term is this one. Following? All right. And, well, actually, yeah, so my AR is negative 5 over 4. And then I know my... All right. Back. Okay, so for here, then what you want to do is sub in your 5R. That's my A. Equals negative 5 over 4. Divided by 5. R equals negative 1 over 4. All right. And now why are we doing this? It's because for a series convergence, this is not all series, it's for geometric series. All right. And so the rule is the absolute of R, if it's less than 1, then it converges. Okay. If the absolute of R is more than or equal to 1, then it diverges. Okay, that's the rule. And so our R here, when you take the absolute, this is less than 1. So it's actually converges. And now they're saying find the sum. And the sum is A over 1 minus R. That's your equation for the sum. And so my A is 5 over 1 minus my R is negative 1 over 4. And so this is plus 1 over 4. And so this will become Let me actually put in the calculator. 5 divided by 1 plus 1 over 4. This is equals 4, which is our answer. So that's right. All right. Moving on. Which of the following are not a geometric series? And so remember, your geometric series is your r to the n minus 1 a. It looks something like this, right? And so how can you identify is if you can manipulate the question so it looks like this. Okay, and so how can we manipulate these questions so they look like that? All right, so the rules for your geometric series is that one, something just fell, I have no clue what. One is that it's the sum from n equals to 0 of your a, r, n minus 1. That's your first one. Okay, let's delete this gibberish. All right, your second one, however, or, so this is or, n equals 1, but your AR is a to the r to the n. Okay, and so now that we know these two rules, we know this starts at 4, this starts at 5. That takes 2 out. Okay, and so now here, this is n to the 0. That means I have to make it n minus 1 to confirm that it's a geometric series, because right now it's not n minus 1 format. So just because it equals 0 doesn't mean it's geometric, right? And so to confirm, what I could do is raise the whole thing to the n. If you have 7 to the n and 29 to the n, I could just write 7 over 29 all to the n. Right? Now, this is still not n minus 1. How can I make it n minus 1? If I take a 7 out, right, I took a 7 out. So if you remember, let's say I have an x3 and I take an x out, what I'll get is x and then x2, right? Because I'm minus 1. Or if I rewrite it, what it actually looks like is x, still x3, but x3 minus 1, right? So if I took 7 over 29 now, this becomes 1n minus 1. Now we're in the format of a r to the n minus 1. This is geometric, all right? Same thing here. We have 2 to the n, what do you call it? Exponent and n squared. Now, how can we manipulate this so that we can get the format that we need? All right, so for this last question, it does look a little bit tricky, but in order for you to do a geometric series, obviously we have these two here, but the other thing is also, you want to ask yourself is, can I get it in n minus 1? And I know you're probably going to think like, oh, is that what it depends on? Is there other tests? According to this course, we don't cover more advanced math that will let you confirm this better. But the other way is you can ask yourself, can I take a constant out? Because we know this is AR. This is a constant. This cannot have n, right? And so your question is, can I get a constant out? So if I try to take a constant out, what I could do, like n squared, 1 over 2, and this is the n, right? Now I can take this n up here, and I'll get n squared 1 over 2 all to the n. And then I can take 1 over 2 out like we did earlier, and what I'll get is 1 over 2, 1 over 2 n minus 1, n squared. And you see, this is where we get to now. We did get our constant out, which is, that's one thing that will tell you, you know what, maybe this is geometric. But after you get to this point, you can't turn this into just an n minus 1. Now, why is that? Is because you have n as a variable. You can never turn this into, you can never take this away or remove it. And also you can never make this into like take it up to an exponent like this in n minus 1. And that's how you know that this is also not the case. Also, it says which of the following, so we know there's only one answer. All right, this section is also post. This is week 12, which is on the paper exam, but not the online portion. So we're going to skip past this. Now we are going to head into some differentials. Ooh, fun stuff. All right. All right, so when it comes to a differential equation like this, and you want to differentiate it, you want to obviously just expand out your y prime. So your y will become dy over your dx equals your x squared e to the x cubed all over sine y. So what you do here is you just take this up, take this to the other side. That's really all you do. And so what you'll get here is y sine y dy equals x squared e to the x cubed dx. And now you can differentiate this normally like you would any other time. And so here, integrate this normally like how you would any other time. And so integrating this side and this side, what you'll get is this is multiplying. And so how can you integrate this exactly? What you can do, let's see, if you do u sub for your y, that wouldn't really help you. If you do u sub for your sine, that also wouldn't help you. Okay, so here I actually grabbed what we need for this equation, which is, if I can just paste it in. This is from the formula sheet. It is a given. Boom. There you go. It is integration by part formula. Okay, go up here. Okay, and so now trying to solve for this, what I have is uv, and then if you guys remember, you have your Liotte, right? And so here, this is algebraic, which is your a. This is trig, which is your t. And since a comes before t, that means your y gets your u. So your u becomes your y, and my du is just dy, and then my dv takes the rest, which is sine y dy. And I made a mistake here. This is actually, I don't remember if this is my v or my u. This might be my v. And I'm supposed to integrate this part, and I'll get, yeah, du. Oops. Yep, I messed it up again. This is dv. Yeah, and this is v. And this will become, the integral of this is negative cos y dy. And so now plugging this in, I'm just separating the integral. And so here I have an integral of y sine y dy. And I applied the integration by part on it. And so my uv is y, and my v is cos y negative. And looking at the answer, I'm not sure, is the integral of sine, and this is also on the formula sheet, let me check. Yeah, it does look right. The derivative, the integral of sine is negative cos. And so far so good here. Minus my, what do I have here? My v du, which is my v is negative cos, so the integral of negative cos y, right? And that's my v. It's just everything's in red, so it's hard to see. That's my v, and then my du is sine y dy. All right, and here now I'm gonna integrate this. Integrating this is a simple u sub. So your u, I'll put it as my sine, and then my du is cos, right, dy. And so now when I substitute in, this will get y cos y minus the integral of this. Well, we said it will be u. U will take my sine y. Du will take my cos, but I have a negative. So taking this negative out will make this actually a plus sign, right? And so after this, what I'll be getting is integral of u. And so when I integrate u, I will get u to the 2 divided by 2. I'm looking at this right. Yep. So I get u to the 2 divided by 2. I don't think I'm missing anything. Okay. And here, obviously, we got r plus c, but we'll ignore it for now. Subbing in my u, I get negative y cos y plus sine squared y all over 2. Now, this does not look like this for now. So, how can I make it? It's pretty close. So I probably made a mistake either somewhere. Let's see. Oh, I caught it. Silly mistake. I put here dv instead of it supposed to being du, which is just dy. And so that threw off my calculations here. Simple mistake, simple fix. And so let's return this to normal. So this is minus, right? I have negative cos, which is my v, and my du is just dy. Okay, now integrating this, I'll take the negative out, so it'll be a plus, and then the integral of my cos is sine, and it's I'm not even sure if it's negative sign. Actually, I'm pretty sure it's positive. Positive sign. This always messes me up. I actually lost the mark on this on the midterm for my negative. Okay, so now just to match it with what they have, they pulled out a negative. So if you pull out a negative, what you'll get is y cos y minus sine y. Right? I just pulled out a negative. That's all I did here. And so did they flip the other side? Actually, we'll do this last step at the end with the negatives and see what's wrong with it. Maybe it's even my integral. Anyways, now doing the right side. So this is equals my right side is the integral of x to the 2 and then x cubed. This is a simple u sub. So this will be a u sub. I don't know why I wrote it up there. U equals x cubed du equals 3 x squared dx. Take 3 to the other side, du over 3 equals x squared du. So my integral x to the e, x to the 3 will actually turn into e to the u du over 3, which is, I'm going to take a 1 over 3 out of the integral. I'm doing this fast because you're supposed to be good with your integrals already. That's what I'm assuming. All right. And now my e to the u is just e to the u. So that's e, and my u is x to the 3. Right, and then I got my plus c. Now the only thing we messed up here is my negative and positives. So I am pretty sure I probably messed up the integral going from sine to cos and cos to sine. I'll have you guys deal with that, but as long as you guys understand the path, that should be good. The area inside one loop here. I had to pause the video and restart, unfortunately. Okay, so the area inside one loop of r equals cos 3 theta. First thing you want to do is draw this. Right, and so when you're looking at something like this, since you have 3 here, this tells you that there's 3 of them, right? And so that's, there you go, right? And so we're looking for, if you know the area formula, it's the integral of 1/2 your r squared d theta. Okay, and so doing this, you'll get the integral of 1/2 of your cos squared your cos squared 3 theta d theta, right? And so what's your bounds? Your bounds are going to be the areas here. And since we know the loop starts and ends at 0, we can set our r at 0. Right? And you take cos to the other side. Cos inverse of 0 is pi over 2. And so this is pi over 2. Right? And divide it. Now, the other thing you can do here, how many occurrences does your cos repeat? So if we go like this, and we know cos starts like that, right? And we know it starts at 0, and it repeats every pi, right? And so if we have pi over 2, if I add pi, I will get my next section, right? So if I add pi, I'll come here, right? And so if I do pi over 2, and I add pi to it, I'll get 3 pi over 2. So there, look, 3 pi over 2. Now this is not necessary, because what you could do here, divide by 3, so you'll get pi over 6 equals your theta, and comma 3 pi over 6, which is the same thing as saying pi over 3, right? But since we know it, so right now, since we know the angle here is your pi over 6, or sorry, up here is your pi over 6, and you can take it from pi over 6. You can either take it from 0 to pi over 6 and times it by 2, or you can take it from pi over 6 to negative pi over 6, right? And so that's what I'll be going with. And so now taking this, plugging into here, what you'll get is integral from negative pi over 6 to pi over 6. 1 over 2 cos to 3 theta d theta. Now I'm going to do this on the side here, the integral part. Right, now cos 2, this is your half angle formula, which equals 1/2 times 1 plus cos 2 theta. But since this is 3 theta, becomes 6 theta. So when I plug it in, I'll get 1/2 1 plus cos 6 theta. All right, now multiplying the half in, I will get 1/2 plus 1/2 cos 6 theta. Now obviously, as I have this 1/2 on the outside, multiply it in again, I will get 1 over 4 plus 1 over 4 cos 6 theta in my integral. Now integral of 1 over 4 is just theta over 4, plus the integral of 1 over 4 cos 6 theta is the 1 over 4 will stay, right? And what I'll get is sine theta. I'm not sure if this is, yeah, no, it is positive sign. Positive sign divided by, well, oops, I messed up part here. 6 theta divided by 6, and multiply, so you'll get theta over 4 plus sine 6 theta all over 24. And you want to take this from your pi over 6 negative to pi over 6. Okay, and when you take this, you should get your pi over 12. All right, what do we have here? Yeah, see, so they actually drew it here, and it's the same drawing we had. That's great. Now find the area inside R, but outside R1 over 2. And this is pretty simple. Your equation for this is the same equation, except you're going to add an extra R. And so your equation is going to be the integral from A to B. I put beta, but you could put B. 1 over 2. And instead of R squared, what you'll have is R1 squared minus R2 squared d theta. Okay? Now your integral, your bound, is the same. Well, actually, it's not quite the same. That's a mistake on my end. What you want here is, this is the area you're looking for. Okay? So you want to find these points, because that's where you're integrating from. Okay? And so how do you find these points? You make the two equations equal each other. So 1 over 2r equals cos 3 theta. Take cos to the other side, you get cos inverse 1 over 2 equals 3 theta. And what this will equal, let's see, cos inverse 1 over 2 will give you pi over 3 equals 3 theta. Divided by 3, you'll get pi over 9 equals theta. And obviously negative positive. And now coming back here, that means we're going from negative 9 all the way to 9. 1 over 2. R squared is cos squared 3 theta minus R squared is just 1 over 2 squared, which is 1 over 4. I am skipping steps here. Let me know if you, I guess you can let me know if you don't understand. Oh well. Ask ChatGPT. Right? And so expanding my half in, I'll get 1 over 2 cos 2 3 theta minus 1 over 6. Integrating this, what I'll get is, I mean, here you can technically take the half out and apply it in. I'll just keep it. And so here, what we have is 1 over 2. We're going to use half angle again. And since we did it up here, what did we get? We got sine 6 theta divided by 6 times the half. So we get sine 6 theta divided by 6 minus the integral of this is just theta over 6. And then you want to take this. So what this equals is sine 6 theta all over 12 minus theta over 6. And this whole thing will go from negative pi over 9 to pi over 9. All right, integrating this, we have here, do a u sub. Right? Now, sub it in. What you'll get is 1 over 2, the integral of your tan inverse u dx. Now, you can't really integrate this. There isn't a rule, there isn't a formula. You can't u sub this, you can't convert it. So what you can do here, you have to use integration by part, unfortunately. And our integration by part formula equals uv uv minus the integral of v du. And so taking this, obviously my u is going to be my tan, and so u equals tan inverse of x, or of, well, it would be u actually. So let's change this. Let's actually change this instead. And this, we're going to change this to w dw, because we only take w's. All right, and so now my derivative, my du of tan inverse, and I believe this is on a formula sheet, so let me grab it. All right, so let me pop up my, okay, so the derivative of tan inverse is 1 over 1 plus x squared. Yep, so that's my derivative. And now obviously my dv equals dw, and my v equals 1. Right, when I integrate this, I just get 1. Or did I get w? Yeah, I'm pretty sure I get w here. Yeah, I don't know why I lagged there. Okay, so plug your stuff into the calculator, equation, and my u is going to be tan inverse w times my v, which is w, and this is minus the integral of v du, which is w, and then my du is Jesus 1 over. And so this is not 1 over x, this is in terms of w, right? Yeah, this is a pretty lengthy one. Yeah, and this is going to be v du, and my du is this dw. And so now what I'll get here is, whoops, I'll get w dw. Lengthy. Okay, now I'm only going to do the integral here. So this is going to be integral w over 1 plus w squared dw. What can I do here? Can I do a u sub? I can. What are we going to choose? Y. Y equals 1 plus w squared, and my dy equals 2w dw. Okay, and so now gotta isolate dy over 2 equals w dw. Sub that in, you get the integral of, what do we have here? Gotta plug in that, plug in this. I'll get 1/2 on the outside, and I'll get 1 over y dy. Right? And so now integrating this, Jesus, 1 over 2, the integral is going to be ln absolute of y. But don't forget, we're not done yet, because we got to sub in our y back. So this is 1 over 2 ln of 1 plus w squared. Okay, now I got to take this, put it back here. Tan inverse of w minus my 1 over 2 ln 1 plus w squared. All right, now I gotta take this. This is what I do here. Let's see, what's my w? This is my w. Just trying to confirm that everything is in the right terms. So u equals this. This integral should be in terms of u. What did I mess up here? dv v equals w. No, actually, yeah, that's right. Okay, now I gotta plug it in, and so I'll get tan inverse x squared minus 1 over 2 ln 1 plus x cubed, and this would be our integral. Jeez. I did forget one little part here, which is I still have my 1 over 2. And so what this is actually 1 over 2 x squared tan inverse x squared minus, obviously multiply in, you get 1 over 4 ln 1 plus x to the 4. There you go. Now you can simplify this technically and get a common denominator and all that, but we'll leave it there. Okay, integral of this. This is easy. This is perfect squares, I think they call them. Whatever they call it. I'm not even sure what they call them. But the rule here is you have a couple identities, which is cos. Right, that's your first rule. Second rule. Right, this is your second rule. Third rule is tan squared x equals 1 secant 2x minus 1. And so what does this look like, right? What this looks like is a number and a variable, right? And so your rule is x equals your a sine x. That's what it equals, right? And so what's your a? A is the root of this variable. And so what's root of 100? I don't even know. 10. Okay? And so this x will equal 10 sine x. Take this, plug it in. You'll get root, and you'll know why we're doing all this. Minus, we got 10 sine x squared all over dx. Now when we apply this, I'll get 100 minus 100 sine squared x. Okay, there you go, dx. I can pull out the 100 now. I have 100 now. Oops. 1 minus sine squared x, and you can see what this looks like now. Dx. Now I can take the root of the 100. What I'll get is 10. And I still have my root. Here, when 1 minus sine 2x, I'm going to replace it with cos. Right? And now root and square will cancel out. I'll get 10 cos x. Now that I've simplified this, I can integrate. And I'll get 10 sine x. Well, I don't have dx anymore. Plus c. And I actually forgot my plus c here as well. Okay. What can we do with this one? First thing you want to try with shit like this is your u subs. And what can we u sub here? Can I do x squared plus 1? And du will be my 2x. There's a plus 1 though. So I can't really do that. I remember seeing this somewhere. Okay, so for this question, what you can actually do, I'm gonna start writing in black, but I don't like the red anymore. Okay. So with this one, what you can actually do is split it. And what I mean by split is you could do x over x squared. Let me write this better. Um, and what you could do is split it. So x uses. All right. So for this question, what you can actually do is split it. So you'll get x over x to the x squared plus 1. And this is going to be plus 1 over x squared plus 1. Right, now when you integrate this, these two will actually cancel out. I'm thinking, can I keep them at the bottom and use them to my advantage? No, I don't think so. So these two cancels out. What I'll get is 1 over x squared plus 1 plus 1 over x squared plus 1. Now, how can you integrate this? By partial fractions. And so this is going to be two different integrals. You have an integral here, and you have the integral here. The integral of this is actually an equation. And so if I pop up my little formula sheet, I know this is actually tan inverse. Always check your formula sheets, guys. Now this one, let me see if there's another formula for that one. No, there isn't. So this one's actually partial fractions. And so if I do this in partial fractions, what this will equal to is a over my x plus my b x plus c over my x squared plus 1. Right? And so cross multiply, you'll get a x squared plus 1, right? Plus bx plus c, cross multiply, you'll get x. Okay? And so now, when we want to find my b and a, how can I find my b? So don't forget, this is together like this. There you go. All right. And so now, 1 equals this function. And I turn one of them to 0. If I sub in x at 0, this whole term will go to 0 because this x will become 0. So what I'll get is a 1. Okay, so that's what I'll actually get because this will also go to 0. And so now for my other variable, what I can put is let's see what can I put here? X at, I know my function is 1, so the a actually goes away. So I'll get x squared plus 1. And then plus I have b x plus c x. That's what it looks like. What can I choose here? If I choose -1, at least this whole term will go to 0. Well, actually this is square, so it won't. So one thing I could do is isolate for either my b or c and then plug into my second equation, right? And so that's what we're going to be doing. Let's do that. Hold up, I just got to fix something. Okay, so back here, I'm gonna sub in I'm gonna sub in 1 into my x actually. And so I'll get 1 equals 1 plus 1 plus b plus c, and this will go to 1. That's what I'll get. So I'll get 2. Take 2 to the other side, I'll get 1 minus 2 equals b plus c, right? This will be -1 minus c equals b. Now I need another equation. And so x at, let's say 2, will be 1 equals 2, so that's 5 plus b 2 plus c times 2. Okay, and so my 5 comes to the other side, I get -4 equals, multiply this in, I will get 4b plus 2c. Right? Now I'm gonna plug in my b in here, and so what I'll get is negative 4 equals 4 times negative 1 minus c plus 2c. Multiply this in, I'll get negative 4 equals negative 4 minus 4c plus 2c, which equals negative 4. I'm going to take this negative 4 on the other side. It will be plus 4, so this will actually equal 0. And then negative 4 plus, that's negative 2, so c is 0. Okay, so now that I got this, I'm going to go up here, plug it in c. I'll get negative 1 equals b. Right? So now that I got all these values, I'm going to go to my original function, plug them in. And so I'll continue it here. Well, I get my a is 1 over x plus my b, we got negative 1, x, c is 0, so plus 0, I'm not going to write that. And negative 1x, I'm not going to write that either. I'll just turn this into a minus. So this will be x over x squared plus 1. All right, now I'm still not done. Now I can integrate this, and so integrating this one will just be my ln x, right, minus the integral of this is a u sub, so u equals x squared plus 1 equals du 2x dx du over 2 equals x dx. Sub that in, what you'll get is 1 over u, which is ln 1 ln u, and obviously I have 1/2, so let's not forget that. Ln absolute x squared plus 1. There you go. Now take this, plug it here, and so what I got is ln x minus 1 over 2 ln x squared plus 1 plus c. All right. Okay, so I just confirmed the answer, and this is right. Moving on to the next one. What do we have here? This, I believe, is the same thing as if I were to rewrite it to, this is negative, so this is actually cos 3x all over sine x square rooted to the power 3, and damn, that looks ugly. There you go. So I know obviously I gotta replace this with something. I'm thinking to do a u sub, but can I derive my root x sine? Let's see, because I have a feeling that this starts with a u sub. So let's see. U equals root sine x, and so my du will actually equal the 1 over 2 will come, and then I will get, well, yeah, this is not gonna take me anywhere, I don't think. I'll get sine x, this becomes negative 1 over 2. Oh, interesting. Negative 1 over 2, and then I gotta multiply it by the integration of by the derivative of the inside, which is cos x dx, right? And so if I actually take the half on the other side, I'll get 2 dus equals, this is negative 1/2, so this is actually cos x all over sine x root dx. And so actually when I sub this in, what I will be getting, I'll get rid of this, so I'll get a cos squared, and this one I will get a sine root to the power 3 power 2 this time, right? Which is, this is a good thing. That means we're going somewhere, we're getting somewhere. And what can we do here? Can I set my u to the whole 3? Let's try that. Let's try setting my u to the whole denominator. Actually, wait, no, I made a mistake here. Oops. Going back. Yeah, this is actually pretty good. It's actually pretty good, because when I sub it in now, what I will be getting is, let's get rid of this. Let's make this look nice and pretty. Got my integral. I'm not going to take my bounds just yet. And so now when I plug this in, what I'll be getting is cos 2x at the top divided by root sine x at the bottom squared du. Right? And then this is 2, so the 2 is going to go outside the integral. Don't need that. Okay, now what can I do? I have my u as the root. So now what I got actually is the integral of cos 2x all over u squared du. So we're getting somewhere here. And I take this and turn it in terms of, yeah, okay. So I can actually take this and turn it in terms of sine. Because I have a sine here, so I might as well turn it into sine, you know what I mean? I'm going to use this identity. It's kind of, you figure it out as you go. I find that, to be honest, I love integrating. It's pretty interesting comparing to other things. Right? Now what I can do is take my u, square it, equals sine x. Right? And so now I know sine x equals u squared. Take that, plug it in here. Everything is going to be in terms of u, right? And so what I'll get is 1 minus u squared all squared, right? And then all over u squared du. This is, I thought that works here. I guess not. Okay. Du. All right. And now what can I do here? Let me rewrite this. Okay, now integrating this, what I will get is 1 over u. I'm not going to integrate it yet. I'm just going to split it. Minus u4 over u squared du. Right, I just split it apart. And so I can now integrate the first part. My first integral will be, well, this is technically u to the negative 2 plus, so it'll be negative 1 over u. That's my first integral. All right, minus. Now the integral of this, this will actually subtract, so I'll just get u squared. So I'll just get u squared, and then integrating u squared is u to the 3 over 3. Right? There you go. Okay, and now all I gotta do, this is integrated. All I gotta do is sub in my u back, which is root. So this is negative 1 over. For a second, I thought I didn't integrate this. Okay. Sine x minus root sine x all to the 3 divided by 3. And then obviously you want to take your bounds, which are from root 6 to root 3. All right. And that's the answer. I'll confirm it, or you guys confirm it. No, improper integral. They're so nice for telling you that. But how do you know it's improper? When you plug in your 10 here, 10 minus 10 is 0. You're dividing by 0. This is improper. You can't do it. What can you do when you have an improper like this? Is you'll have to split it, and you take the limit as n approaches, as your x approaches that. And so limit as my x approaches 10. That's what you want to do. Well, actually, not x. I would do w approaches 10. Okay. Now, am I approaching 10 from the left or from the right? So I'm going from 0 to 10. So clearly, I'm approaching from the left. All right. Now, dx, what I'll have here is now 1 over root 10. So actually, I'll this is a root, so negative 1 over 4. Oh my god, I'm trying to rewrite this, but it's giving me such a hard time. Alright, so what I'll get is the integral from 0 to w now of 10 minus x of negative 1 over 4. There you go, dx. Now we can actually take the integral for this part. Okay, so integrating this one, you want to take the limit as w goes to 10 from the left. And my integral of this, what you'll do is you'll integrate the top, so you add 1, which will become 10 negative x, or minus x, 3 over 4. You want to bring your 3 over 4 down, and then you divide by it, but obviously flip and multiply. So this is what it will look like. And you divide it all by the derivative of the inside, but that's just 1, so I'm not going to write it. Okay, now I still got to take my integral from 0 to w. So you got to sub it in. I got 4 over 3, 10 minus w, right? Of 3 over 4. Then minus my, 4 over 3, 10 minus 0 to the 3 over 4. So, simplifying this. Obviously, we're still taking the limit. We haven't taken the limit just yet. Right? Now, if I were to simplify this, this will just be 4 over 3, 10, 3 over 4. Okay? So that's a solid number we know is there. The question is, where does this limit go? Now, obviously, if this goes to infinity, now this is not a negative, right? So if you were to rewrite this, this would be your square root of 4 to the power 3. Okay? And so when you take the derivative of this whole thing will go to infinity. Minus something, this whole thing will go to infinity. And so it diverges. Alright? Okay, so I actually made a mistake here just now. I was looking at it and I was like, why does this look like that? This doesn't go to infinity because this is, I thought the limit goes to infinity, but it actually goes to 10. So you just do, you plug in 10 minus 10, the 3 over 4. This whole thing will go to 0. So your answer is negative 4 over 3, 10 to the 3 over 4. And I'm going to go confirm this answer real quick. All right. Another little mistake I caught is actually right here. Well, that was the fixed version. But after I integrate this, you have to divide by the derivative of the inside. And the derivative of the inside is actually a negative 1. I didn't write it because I thought it was a 1, but it's a negative 1. And so this is supposed to be a positive number. That's all really. Okay. Moving on to the next one. What do we have here? Arc length, which is an equation. Okay, we're almost done. So for this one, take your limit, improper integral, as w goes to infinity, w to 2, you have x over x plus 2 dx. Now, let's say I'm going to integrate this separately on the side here of my x over x plus 2 dx, right? Alright, so what we got here is a u sub, and so the u sub is going to be x plus 2. My du is going to be dx. Now I can isolate this for x, right? Now I do know my u goes here, so integral, this will become something over u squared. Now what is my u? This equals u minus 2 equals x, right? And so I can sub that in. Du now, right? And now that I got this, what I can do is separate this into two integrals. So this will be u over u squared minus integral of 2 over u squared du. Right, now this is obviously 1 over u, which is ln of u, minus this one is the 2 comes out, so the 2 goes here, and then u to the negative 2 plus 1, so you'll get u to the negative 2 plus 1, bring it down, you get negative 1 over u. And so this is actually, I will get positive 2 over u. Now plug your u in, which is x plus 2. So this is ln of x plus 2 plus, I already know this diverges. I got 2 over x plus 2. Now, obviously, well, it doesn't diverge just yet. So what I'll do is I gotta take my limit, which is from 2 to w of, and then limit as w goes to infinity, right? Now, when I do this, it's gonna be some term minus some term. But since this goes to infinity, that means it's gonna make the whole thing goes to infinity, right? I mean, this one will go to 0. This one will go to 0. But this one is gonna go to infinity. And if this one goes to infinity, the whole thing will go to infinity. So this goes to infinity, therefore diverges. All right. All right. Next question is arc length. Last 2 questions. All right. So for this one, is parametric equation is L equals b a root dx over dt squared plus dy over dt squared. I'm only gonna set this up, so I'm not gonna really go. And so dx over dt is just t, and dy over dt is just t squared. Okay, so you plug those in, and you'll get t squared plus t to the 4 dt, right? And your bound is going to be from 0 to 1. And that would be your L. Now, if you were to integrate this, what can you do? You could probably pull out a t, right? You can pull out a t squared. There you go. And then you can here take the, what do you call it? Take the derivative of this. And so what I'll get is t, right? Well, not the integral derivative. Take the square root. And so you get 1 to 0. And here, 1 plus, this is secant squared x equals 1 plus tan squared x. Now, that means your a, that means your t equals a tan x. What's your a? Is just 1. Right? So you take this, you sub it in. What you'll get is 1 plus tan squared x. Take this. Obviously, I still have my root. Take this, replace it with your secant. And that square root now cancels out. I know I said I'm only going to set it up, but it's a quick one, so might as well. Sec x. All right. Well, sec t actually. All right. Now you got to integrate this, and I believe this is integration by parts. And so this will actually be t sine. What's your, I'm trying to remember what my secant is. My secant, no, is 1 over. 1 over. So it'd be t over cos t dt. And from here, I'll have to probably do integration by parts and go from there. All right. So good luck. This question is, I believe I've solved this on my other lectures. It's just an equation that is given, by the way, for this type of question. Let's see. Do they have it on the formula sheet? Yeah, Newton's law of cooling is given. So this is really just an equation. And so I'll leave this one. All right. So thank you guys, and good luck on the exams. Hope this helped. If you guys have any questions, do comment, and I'll try to help you guys out. Thank you for watching, and see you on the next course.